Embryology in relation to taxonomy. Example is Strapa and Exocarpus. Embryology is the study of microsporogenesis and megasporogenesis, gametophyte development, fertilization, and development of endosperm, embryo, and seed coats. Although the possibility of utilizing embryological characters in taxonomy was indicated by some earlier botanists like Hofmeister and Strasburger, the role of embryology in solving taxonomic problems was first brought into prominence by a German embryologist Snarf in 1931. Embryological characters, being less prone to adaptive stress, are relatively stable and have acquired great significance in taxonomy, especially when external morphological characters are inclusive and misleading as a result of convergence. Thus, embryological evidence have been used in solving taxonomical problems at almost all levels and have helped to resolve the doubtful systematic positions of several taxa. Embryological evidence have strongly supported the proper placement of certain disputed families and genera, once regarded to have doubtful systematic position. Bentham and Hooker in 1883 included the genus Strapa in the family Onagraceae. On the other hand, Riemann, Engler, and Diels and Hutchinson included the genus Strapa in a monogeneric family Hydrocariaceae, which is now renamed as Trapaceae. P. Maheshwari made a study of embryological characters of Strapa and showed that it vastly differs from Onagraceae. Ram in 1965, who made detailed study, points out that the difference in embryology of Strapa and other members of Onagraceae. Coming to the characteristic feature of the pollen of Strapa and Onagraceae, in case of Strapa, the pollen grains are pyramid-like with meridional crest, whereas in case of Onagraceae, it is bluntly triangular. The next character, ovary. The ovary in case of Strapa is semi-inferior, bilocular with one anatropous ovule in each locule, whereas in Onagraceae, the ovary is inferior ovule, mostly tetralocular with many ovules on axile placentation. Another character is regarding the female gametophyte. In case of Strapa, the celagial megaspore is functional and it is of polygonum type, whereas in case of Onagraceae, the 4-nucleate embryo sac of Oenothera type and the micropylar and the celagial megaspores are frequently functional. Coming to the next character, that is endosperm. In case of Strapa, it's absent. The nucellus will provide nutrition to the developing embryo, whereas in case of Onagraceae, it is nuclear endosperm. Next, with regarding to the embryo is of solenoid type in case of Strapa, and the suspensor haustorium is well developed. In case of Onagraceae, it is of onograd type and suspensor haustorium is very short. Fruit. The fruit in case of Strapa is one-seeded drupe, whereas in case of Onagraceae, it is loculicidal capsule. On the basis of above differences, it can be easily justified that Trappa can be removed from Onagraceae and included in a separate family, Trapaceae. Coming to the next one, that is Exocarpus. The systematic position of Exocarpus has been debated at length, and some even suggested that it is not an angiosperm at all and it should be included under Gymnosperm as a separate family, Exocarpaceae, to be placed near Taxaceae. Gapnepsin and Bauria, who argued for Gymnosperm's position for Exocarpus, pointed out Gymnosperm's characters such as naked ovule, articulated pedicel, and presence of pollen chamber in the embryo sac. Lamb in 1948 assigned a position to Exocarpus in his Proto-Angiospermae along with Casuarina and Salix. Smith and Smith in 1942, who studied the floral anatomy, opined that Exocarpus is a specialized genus belonging to the family Santalaceae. Swami in 1949, who made comparative anatomical studies of stem and node and also the pollen structure, supported the review of Smith and Smith. Ram in 1959 made a detailed embryological study of 3 species of Exocarpus, namely Exocarpus cupressiformis, Exocarpus sparteus, and Exocarpus strictus, and found out the following features. That is, the flowers have angiospermic character. Anther wall development follow the angiospermic feature, and the pollen is shed at 2-cell stage. Embryo sac is of polygonum type. The primary endosperm nucleus divides earlier than zygote and produces a micropylar and a sellageal chamber. The sellageal chamber divides and produces a lobed haustorium. In Exocarpus cupressiformis, the haustorium is multicellular. The micropylar chamber shows repeated division to produce the main body of the endosperm, and the development of zygote leads to a dicot embryo. The seed is not naked. The endosperm is surrounded by the pericarp. On the basis of above characters, it can be safely said that Exocarpus is an angiospermic and belongs to Santalaceae, even though it shows some differences in embryo sac and suspensor in the embryo. Thank you.